Okay, continuing on our function notations. Now, just to make sure, it doesn't always have to be f of x, can be g of x, z of x, v of x, doesn't actually have to be x as the independent variable. So in this case, we've got g of x. Now, it's some sort of rational function, so very briefly, without doing too much interesting things about it, this graph looks a little bit like this. This is one of those ones with the asymptotes and the interesting domain. So let me just draw those axes in black. Okay, so what's happening is, so if you were to type this into your graphics calculator, which I hope people would do at this point, have a rough idea what's happening. So we can see that we have some sort of domain where the x value cannot equal to 4. And that will come up in a minute with one of these questions. Anyway, first up with a couple of straightforward questions. We'll only do a couple of these for part A. G of 2. So I'm going to write the function out with brackets where the x goes. So I don't have to do too much in the way of thinking. Wish I could remember which my blue pen was. So instead of x, I'm now going to put a 2. Now, to evaluate this, 2 times 2 is 4, plus 3 is 7. 2 subtract 4 is minus 2. And we will always rewrite our fractions with the negative on the top. Okay, just walk our way through to the next question. We have g of 0 equals 2. So, using the rule, I'm going to put a 0 where the x was. I can now see 2 times 0 plus 3 is 3. 0 take 4 is minus 4. And again, I'm going to redirect it so the minus is on the top. So there's the straightforward substitution. The half one's a little bit more interesting. I'll let you do that one while I move on. Okay, through the question again. So find a value of x such that g of x does not exist. So these words here mean some sort of asymptote, or the graph for some reason doesn't exist. So this line here, as I've done in the sketch, this line here indicates divide by 0. If I have 2x plus 3 over x take 4, what could I put in here that would make the bottom equal to 0? And hopefully everyone can spot that it would be 4. 4 subtract 4 would be 0. Now what would be on the top? 2 times by 4 plus 3. Doesn't really matter what's on the top. 11 divided by 0 is undefined. Error on the calculator. This is what it would look like on a graph. So here we have right there, on everywhere on this vertical line, x equals 4. Y can be any number. So in fact, this is not on the graph. This is undefined. So that is what's meaning by a line like this. X does not exist. So the graph does not exist when x equals 4, because 4 take 4 would be divided by 0. Getting repetitive now, time to move on. For part D, getting a bit more interesting, looking for when g of x equals minus 3. It's giving me the answer this time. I'm not sure what's going on. This is a solve question. This question will finish with x equals a number. It will not finish with g of 2 equals 10. It's not that sort of question, because it says find x. Another word for solve. What do I do? What I do is where I have g of x is equal to 2x plus 3 over x take 4. I have no number to substitute for x, but I have a number to substitute for g. of x, i.e. minus 3 goes here. Now, do you believe everybody knows what to do now? Cross multiply. Well, not really cross multiply, just we're going to bring this part over here. Minus 3, x take 4 equals 2x plus 3. I think we want all the x's on that side and all the numbers on this side. So minus 3x plus 12 equals 2x plus 3. Bringing this x across, we have minus 5x equals 3 take 12. And our final solution is 3 take 12 is minus 9, and we divide by minus 5, and we have 9 on 5. So looking over here, that when x is 9 on a 5, which is about 2.5 or 1, almost 2, that the graph would be at a height of minus 3. So, apart from substitution of the x value into the graph, as we saw in part A, we can also substitute the y value, or the g in this case, to find the x, hence a solved question. So what that question really asked is, I'll make a dot over here at minus 3 and say, hey, what is the x number that makes that happen? Okay, slightly different question, but still using the ideas of substitution notation.